Welcome back to the Gas Out Garage. Our latest project, this delightful piece of equipment has found its way into the Gas Out Garage. So what this is, it's like a, excuse me, like a lazy Susan for welding, like a cake stand that rotates. So you put the piece that you're working on, and rather than have to turn it, stop welding each time. Bear in mind, I'm not a welder here, no welding expert. You press on this foot trigger here, and this rotates. This rotates around, and hope the idea is I think you can carry on welding like a circular piece, like an exhaust manifold, or for example a tube, or whatever, without having to stop. So this has come as faulty. It's never known to have worked. It came like this, so someone's been inside it before me, which always fills you with confidence. Let's have a look here. So the first thing that's jumping out at me is this failed sticker. So what's that, 2006? Perfect, so it's 2022 now. So it's a good one. If you're C. Edwards and you're watching, give us a comment in the description and let me know what the fault is. That'd be beautiful. So power, forwards, reverse, stop, and I guess this is speed. Oh yeah. Oh, she goes all the way to 11 and back round to 0. Oh, it just goes. Oh, it just goes round and round. Never mind, I'll look at that later. Have a look inside. So the first thing I'm going to do is take a look for any obvious damage to components, burnt out components, dry solder joints, loose connections, anything like that. I mean, to be honest, looking at it, the first thoughts I had was to extract all of this gubbins and replace it with an inverter. They're so cheap now, you get them for like 30 quid. It'd be a much better way to do it. But if there's a simple fix in here, let's try that first. So to be honest, the first thing, actually just looking through the camera lens, jumping out on me here, is this cable. It looks like it's melted. I'm trying to zoom in and get there as good a picture as possible. The sheathing on it, on the earth cable, CPC if we're being correct, looks to have melted. Right, I'm going to investigate that further before we go any deeper into it. So melting like this, I'm going to call this earth, but yeah, CPC for the pedants, suggests to me that a lot of current has flowed through here, heating this up, and the only real reason current should be flowing through the through the earth conductor is in the event of a fault, i.e. a live conductor has touched the frame, because this is the ground is connected to all the metalwork of the machine. So I've got the meter in continuity just so you can hear it audibly beep, you know what I mean. So when I put it on any metalwork of this machine, we should expect a beep. Now when we put it on the live or the neutral, we shouldn't, because these should be not touching any metalwork, extraneous metalwork of the machine. So that's a neutral conductor, and that's showing me dead short to earth. Okay, that's fallen out, perfect. I'll put it back in and we'll go to live, and we're getting the same again. So what I'm going to do now is I'm going to isolate the motor from the control box and try and figure out if the short is in the motor or the control box. Right then, I've disconnected the wires, all the wires to the motor. There's only 4, so I imagine that's to do with the speed controller in there. Just to recap then, so we're back on the one probe on the ground stud. Again, we've got continuity, which we would expect, that's good. But now if we go over to the live and neutral, so I'm on the neutral input there. nothing, good, open circuit. And the live, nothing, good, open circuit. That says to me that the fault lies either in the cable to the motor or the motor itself. So what I'm going to do now is I'm going to go between the earth cable for the motor itself and its individual wires. Well, I've removed some of the electrical taping. You can see where the earth conductor there has been cooked through overheating, probably due to a short to earth fault. And let's just do the measurements now then. Okay. So yeah, that's our first one, and we're short to ground. Next one. Okay, that's good. Oh wait, no. Sorry, also short to ground. This one and that one are good. So this pair short to ground. Now what would be really nice if this is a fault on the cable rather than the motor. So next thing I'm going to undo this panel and take some readings in there. Then we can determine if it's in the cable or the motor. If it's the motor, I don't think I'll go any further. It's not worth repairing. Right, I've got the plate off. These two cables seem quite entwined. I think the sheathing is melted and the two conductors are touching together. Oh look, what a surprise. Yes it has. There we go, look. There we go. See look, the two sheathings come apart, the conductors are touching together. Now, if we do our test, we should get open circuit between ground and the conductors. Let's try that now. Right, I've got the crock clips on ground, and I'm just going to go across each conductor again. So open circuit, good. Open circuit, good. Open circuit, good. Open circuit, good. Excellent. Now what I'm going to do is I'm just going to do the resistance between the windings of the motor. So I believe the pairs are labelled up as A and F, so that pair and that pair. Let's see. Two kilo ohms, sounds good to me. We've got here. $370 ohms. Switch it on. Right, I'm going to wire the control box back in and let's give it a test. Right, we're all connected back up in the control box. This thing just floating around here isn't just filling me with confidence, if I'm honest with you, but we'll cross that bridge when we come to it. We're just going to see if it works or film my own death. Yeah. He'll be fine, he'll be fine. Stop, power on. Okay, well, let's go for it. It's a good start. Nope, she still broke. Right, as you see, I added power to it and it still popped the circuit breaker. So I've just done a quick measurement and we've still got a dead short between live and neutral, and the short appears to be on this board. So if I go here and So that's the live and neutral inputs to the board, and you can hear that's a dead short. So I'm going to whip this board out. I'm going to take a look at that. Right, this is the board out. This here suggests to me that someone's been here before. So anyway, let's take a further look at this board. Right then, we had a short circuit between live and neutral on the input to the board, and that was causing the fuse in my house, whatever, to breaker to trip every time because of a short circuit, obviously. So I looked at the components that were between the live and neutral input on the back of the board, followed it through on the solder. I've screwed this back out down so you can't see it, but you get the idea. And I was drawn to this diode here. As you can see, it's missing. It's diode 4. Now, to test a diode, you need to really desolder it from the board. Is the best way to test it. A diode's like a one-way street for current, so current should only flow in one direction on a diode. Unfortunately, you need a diode test function on your meter to test this. What it does is puts a small amount of voltage through the diode, and you should get a current drop in one direction, but then when you switch the leads over on the meter, not in the other direction. This particular diode was allowing current to flow in both directions. Also, now when I measure between here and here, I no longer have short circuit. So I don't have this particular diode, so I'm going to do the right thing and just put it back together without it. I'm sure it'll be fine. In the future I may source the correct diode, but for the purposes of diagnosing the rest of this machine, I'm going to pop this all back together and hopefully give it a try, and hopefully we'll be in luck. Okay, all back together of sorts. Let's hit the power. No smoke, that's a good sign. Oh, power's already on the front. Okay, I'm going to switch this into the... Oh, that's forward, okay, forward position. And foot pedals down here. Alright! The industrial Lazy Susan lives again. Nice! So you can probably hear it pulsing, and what that is, this circuit then I guess must send a pulse like on, off, and then the rotary switch here, the potentiometer, adjusts the width of that pulse to adjust the speed. So now we're going down to the minimum speed. So yeah, it works. I mean, a slight pause, not exactly the smoothest. I don't know if that's beneficial to welding or not. I'm far from the expert welder. I mean, as I said at the beginning of the video, the other way to do this would be replace all that with an inverter where you can adjust the speed, or variable frequency drivers are sometimes called. We can adjust the speed of the motor with that. And if stopping dead is important to you, you can do that with DC injection into an AC motor. But you know, what do I know? The task was to repair this machine, and we've done it. You know, for the sake of this filter's going to be replaced. This was the original one, but it smoked. This one was just, we had lying around, so I used that as a temporary measure. It's far too big for the enclosure, so it'll be getting changed back to one of these, same model as that. We've got the diode that will definitely 100% probably, maybe not, get replaced, and slap it all back together. I think we can go as far as putting a new plug on it, because that's a bit sketchy. Even though it's only the earth, it's still best to have it. So yeah, there you go. There she goes. That's as fast as it goes. So anyone was hoping for a Ghost-esque Patrick Swayze reproduction of that scene, you're shit out of luck, because that's as fast as it goes. Anyway, I'd like to thank you all for watching the video. Really appreciate it, and hope you'll join us on the next one. I think I've got some car stuff coming up, so for all you petrol heads, I've got a really dirt cheap Saxo restoration return to the road, and the van with the failed cam belt. So stick around. Thanks again, guys. I'll have some cake. See ya.